This is the second video of 7.3. We will be looking at dividing rational expressions. And just remember that dividing is the same as multiplying by the reciprocal. So it's not going to be much different than multiplying. We're still going to factor everything, but then you're going to flip the second fraction over. So notice this fraction here, it's a little bit hard to show, is flipped over. The only thing different though is when you are finding the domain, not only is it going to be the denominators of the first two fractions, but also the numerator of the second fraction. So let's look at an example. Okay, so let's look at example 5 in our notes. The first thing we want to do is change the problem to a multiplication by the reciprocal. So we're going to keep the first fraction the same, change the problem to a multiplication, and flip the second fraction over. And now we're back to a problem that we already learned. So let's go ahead and factor everything. The first numerator does not factor. The first denominator, you can take a 2 out. The next numerator factors to x minus 6, x minus 5. This is an easy trinomial. And the second denominator, we can take a GCF out of x, and I'm left with x minus 6. Before we start crossing things out, let's state our domain. X can equal positive 5 from that part. It can't equal 0 because of this x. It can't equal positive 6 because of this one. It also can't equal positive 6 because of this one and positive 5 because of this one, because these two were originally in a denominator. So you're always going to get your domain from, you're going to do the domain from the first denominator, the second denominator, and the second numerator. So again, it'll be 5, 0, 6, 5, and 6 again, but I already have them written down. So now let's start crossing off things that are the same. We have an x minus 5 on the top and bottom, an x minus 6 on the top and bottom, and also an x on the top and bottom. So the only thing I didn't cross off was this 7 over here and this 2. So my answer is 7 over 2. Let's look at example 6. Start off by making the problem both fractions. And let's do step 1 by rewriting the problem as a multiplication problem by the reciprocal. And now we're back to problems like we did on Monday. Let's factor this first numerator. This is actually a harder trinomial. Factors of 6x squared. I like guess and check. I'm going to guess 3x and 2x. Factors of 15 are 5 and 3 or 15 and 1. You got to play around with the numbers. After playing around with the numbers, I got 3x plus 5, 2x minus 3. You might want to FOIL in your head to double check that that's correct. The first denominator does not factor. The next numerator stays the same, and the next denominator can take a GCF out of x. Before I start crossing off, what's my domain? The domain comes from the denominator of the first one, 0, the denominator of the second part, 0, and this one's a little bit trickier. It's not just negative 5, it's negative 5 over 3. I'm not sure why I wrote 0 twice. You don't need to write 0 twice. And also, domain comes from the second numerator, but there's no x up there, so we don't have to worry about that. Now let's start crossing out. There's a 3x plus 5 on the top and bottom. Notice I have an x here and an x here, but it's not top and bottom, so they don't cross out. So now I'm just going to multiply across and get 2x minus 3 times 1 is just 2x minus 3. I have 4x squared times another x, which will be 4x cubed. Double check your final answer. Make sure that you can't factor again. Like the 2/4 does not reduce because of this minus here is added to it or subtracted to it. That's it for dividing. We'll do the monitoring progress in class. I do want to take a moment and look at adding and subtracting just simple numbers. When you're adding two numbers with different denominators, we're going to have to make common denominators. So the common denominator for this problem here, common denominator of 4 and 3 will be 12. So to change the 4 to a 12, I need to times it by 3. So I'm also going to multiply the numerator by 3. So I get negative 9/12. For the second fraction, to make 3 go to 12, I need to times it by 4. So also multiply the top by 4. Now that I have common denominators, I can do negative 9 plus 4, which is negative 5, so I get negative 5/12. Notice when you add and subtract, once you have common denominators, you do not touch them, just carry the 12 over and just add or subtract the numerators. Looking at example 2, I have 7/8 minus a negative. Well, minus negative, same, change it to plus 5/8. I already have common denominators, so just carry the 8 along and go ahead and add your numerators together and get 12/8, which does reduce to 3/2. So my answer is 3/2. Why don't you take a minute and try the 6 problems here.